All right, Nacho, what was it?
I got 5x to the fourth power.
All right, how'd you get that?
Well, I just kind of used Pascal's triangle to expand the binomial.
Oh, dear God, you poor man. All right, no, it's okay. You're just a masochist. What does that look like? Hold on. Camila, go outside, come back in. For real. Go out and come back in quietly. All right, guys, if you look at that, what is that? The limit as h approaches 0 of f of x plus h minus f of x over h. What is f of x? Nope.
X equals x times over 5.
X to the power of 5. So Nacho, what you did is not wrong, but it's way harder. Because if I look at this and identify that, hey, that's the definition of the derivative, that means that this is my f of x, right? And if that's my f of x, what's f prime of x? Exactly what you said it was, 5x to the fourth. Do you see how much easier it was?
Yes.
So, guys, when you see something like that, that's what it wants you to do, okay? It wants you to identify what is this. This is the definition of the derivative. Therefore, what's f of x? And find the derivative.
Did you see me there?
Huh?
Did you see me there?
Good.
Thank you, Miss.
Okay. Do you understand how I got f of x?
Yes.
Okay. F prime is just using power rule. So if you remember, we take the exponent, we pull it down in front, and subtract 1 from the exponent. That was power rule. Good? Awesome. All right, for the next one, it's kind of similar in the sense that what I should do first is simplify this. So if I have x over x to the 1/2, because the square root of x is x to the 1/2,
1/3.
that is the same as 3x to the, what's 1 minus a half?
Negative 1/2.
Positive 1/2, because this one's negative 1/2, and so it's like, if you wrote them out that way, it'd be like 3x x to the negative 1/2, and then you would add them. If it's on the bottom, it stays positive, but you subtract them. Either way, it ends up being negative. So you're going to get 3x to the 1/2. That's way easier for me to work with, because then once I do that, I can apply the same rule as before. So the 1/2 comes down in front, 3 over 2, okay? X to the negative 1/2, or more likely, you're going to see it written this way, guys.
But me say you didn't change the negative 1/2.
What are you talking about? If I wrote it this way, I would add them, right? 1 plus negative 1/2. If I leave it this way, it would be 1 minus 1/2. Either way, I get x to the 1/2.
But I don't understand why you're putting 1/2 if there's no exponent
Where is there no exponent?
in that year.
Sure there is. There's a 1. We just don't bother writing it.
And
Because,
why
that's
that half then?
because the square root is the same as a half from pre-calc. Right? So in pre-calc, we learned that the square root is 1/2, the cubed root, 1/3. The power rule. Whew. All right, guys, the power rule just means that we take the exponent, we pull it down in front, then we subtract 1 from our original exponent. Okay? All right. Now it's asking us for the slope of the normal line. So far, this is the derivative, which would be the slope of the tangent line. So first, let's plug it in, and then we'll flip it. So let's plug in our x equals 4. So I'm going to get 3 over 2 square root of 4, which is what? Can we do it in our heads? 3 over 4. Good. Good. I heard 2 of you do it. That means that the normal is going to be negative 4/3, right? We just flip it. Right? Whatever the slope is of the tangent, the normal is the negative reciprocal. Yeah. Feeling good?
Yes.
Excellent. All right. Let's take a look at this for real now. So far, in order for us to take the derivative of this, we had to go ahead and expand it first and make it look like a polynomial or polynomial-like function, right? The only things we know how to do so far are polynomials. Polynomial-like, meaning it looks like a polynomial, but it might have negative or fractional exponents. And we know how to do basic trig, right? What's the derivative of sine? And what's the derivative of cosine? Negative sine. Good. All right, so for this one, we're going to have to expand it first. So f of x is going to be 2x cubed minus 4x squared plus 2x. Are you all with me so far? Right, we're just plugging that 2x in and multiplying it through.
Yes.
Good. Now I got to do the same thing to the negative 3. So I'm going to get negative 3x squared plus 6x minus 3. Then I can combine like terms. So there's no other cubes. But I can combine the negative 4 and the negative 3x squareds. So that gives me negative 7x squared. Then I can combine 2x and 6x to get plus 8x, and then minus 3. Once I have it looking like a polynomial, the derivative is easy. I just use power rule. What's the first part there? What's 2x cubed when you take the derivative? 6x squared. Good. And then here, 14x, and then 8. And why do I not need to write an x anymore? The exponent would become what? 0, and anything to the power of 0 is 1. So we don't bother. And then what's the derivative of a constant? 0. So it goes away as well. Perfect. Awesome. What does that represent? The slope of the tangent line, or the equation for the slope of the tangent line. Either way. So slope of the tangent line at x. Meaning we can plug in x for whatever value we need and get our slope of our tangent line. All right. I believe you guys already know about both of these men, because most of you guys, I think, learned about Leibniz in, there's some class I know. Students always tell me. And I'm assuming you learned about Isaac Newton because you didn't live under a rock in science class. You don't remember him?
Yeah, Newton. Yes. I think he's so dumb because he's like, if you drop a pencil, it falls, but you were like the third person in the world, so obviously you're going to discover that. And then he became famous for like common sense. I think.
Here's the thing you need to realize. A lot of, when you're learning about what these previous scientists or mathematicians, etc., have done, you have a lot more knowledge than was available at that point. So yes, sometimes it's going to seem like common sense.
If you push something, it's going to move, obviously. Pues,
why?
If it doesn't, then
go push that wall. Go push the wall.
No.
Is it going to move?
No, but I know it's false, obviously.
Push Bean. I bet you he doesn't move.
Yes, obviamente.
This sounds like a challenge. Should we make them do it?
No.
Should we make them push each other? Veronica, what's up?
Didn't Newton like figure out calculus because he was being paid in a competition with another guy who was also trying to figure out calculus?
I mean, I don't know if I would say that they were like petty. To be honest, they weren't even anywhere near each other most of the time. But yes, they were both developing calculus on their own. They both have different notations, etc. Okay. Anyway, in this particular case, Leibniz is the one that figured this out first, and he figured out the product rule of differentiation. So it's going to be this. If h of x is equal to f of x times g of x, in other words, two things multiplied together, then the derivative, so h prime of x, is going to be f prime of x, g of x, plus f of x, g prime of x. Okay? Now, you might also see this written out this way. If you have like h of x equals uv, then h prime of x is u prime v plus uv prime. I don't like that notation as much because I think u's and v's look too similar, and so I find it annoying. But it is the exact same notation. You can plug in whatever you want. If you want to, you can plug A, B, happy face, sad face, doesn't matter to me, right? As long as you understand like what's going on. And truthfully, we're going to do it the first couple times by writing it out kind of a long way. After that, we're just going to kind of do it in our heads because we're smart. Yeah. I mean, this is probably the easiest unit. Yeah.
You said what?
No, I'm serious. This is probably the easiest unit of the 7. You don't like that answer? It really is. But you've only started. What do you mean? Like, it's the first topic. How can you be freaked out already?
I'm liking it.
Good. Okay. So if we take a look at this one, let's rename this because that way it'll help us with this notation. So let's change this to h of x. Let's make this one f of x and this one g of x. Okay? Now let's write out what those two derivatives are. So f prime of x is what if I take the derivative of just that first bracket?
It's
Just this first.
2.
Just 2. And what about g prime? This one's a little bit tougher, but not much.
2x minus 2.
2x minus 2. All right, that's important because remember, h prime of x is going to be equal to f prime x g of x plus f of x g prime of x. And then we're basically just going to plug in all the stuff we know. F prime was 2. G is the longer version, so x squared minus 2x plus 1. F of x is 2x minus 3. And g prime was 2x minus 2. Now, it may not look like it, but that's the same answer as the one before. So let's prove it. I'll do the distribution. Normally, I'm not going to necessarily force you to do the distribution. But in this case, let's do it to prove it's the same, okay? So this is going to be 2x squared minus 4x plus 2. And on this side, we're going to get 4x squared minus 4 minus 6, so minus 10x plus 6. Then we're going to put all that stuff together. And so finally, 6x squared minus 14x plus 8. What do you notice about that and the thing we did before? No. Guys, trust me, by the time we get to the end of this course, you'll be like, oh, I missed Unit 3 when it was so easy. Trust me. This is the most straightforward, easy unit. You're going to like it.
Can we just do the other method? That is way easier.
What method?
The one we did.
Yes. So my next question is this. They are the same. So which one's easier?
The first one.
Probably the first one, right? Not by a lot, but probably a little bit. Now, if you didn't have to do the simplification, these last two steps, maybe this one's a little bit easier. Here's the problem with just being like, can't we just always do that? Let's look at this next question. What is g of x there?
X squared sine x.
Can you turn that into a polynomial? You screwed, right? So now you need to be able to do it. So we need to be able to use product rule to do this now. We have no choice. So let's break this apart. Let's change it again. Let's make this h of x. Okay? We're going to make f of x equal to x squared, which makes f prime 2x. And then we're going to make g of x sine x. And what would g prime be? Cos, good. Cos x. So do you see why we need the product rule now? Is it starting to make some sense? Okay, so we can't rewrite it. So we're going to apply product rule, and then we're going to find the slope of the normal line when we're done. First, we got to figure out what the actual, derivative is so we can find the slope of the tangent line. So our h prime of x is going to be f prime, which was 2x, times g sine x, plus f, which is x squared, times g prime, which is cos x. Are you all with me?
Yes.
I heard at least one no, so I'm going to move this down and write, like if you're having a hard time, always just rewrite it out, right? So it's f prime x gx plus f of x g prime. So if you're having a hard time, write that first step down, write basically the definition of the product rule, and it should help you. All right, so we're there-ish. Now I need to figure out what the slope of the line is at pi, so that I can then find out what the slope of the normal line is at pi. I know, it's really creepy. I don't know what he's doing.
Why is it sine x?
Here?
It's not like multiplied.
Yeah, they're multiplied.
Wouldn't it be 2 sine x to the second power? Like, why don't they?
No, the x cannot go inside the trig. Anything inside the trig function has to stay inside the trig function. There's a few trig identities. You guys don't know them.
No.
No, I know. You should know them, but you don't. Because they don't teach them to you here at this school. Unfortunately for your sakes. Okay. So I'm just going to plug in pi. So this is 2 pi. What's sine of pi?
0.
Nice. We like that. All right. And then this is going to be pi squared. What's cosine of pi?
Negative.
-1. Good. This part goes away, right? Anything times 0, 0. So h prime of pi is actually just negative pi squared. Perfect. What would the normal be then?
Why did you change it?
Oh, I didn't change anything. What do you mean?
Yes.
What did I change?
Pi.
I put the negative in front. Why would I put the negative in front?
Because you're multiplying by -1.
Right. And if I put it as pi squared minus 1, somebody's going to think it's pi squared minus 1. All right, so if I have the slope of the tangent line, how do I get the normal? Negative reciprocal, so this normal slope is going to be 1 over pi squared. Easy enough? Y'all feeling good? Should we do some extra examples? Do some actual ones? Actual examples. Actual. I can't speak well, I'm sorry. I blame Maho.
What am I?
Camila, you look so comfortable for us. You don't like have to try and squish into the corner. All right. So we're gonna use the product rule now to define or find all of these ones. Now, in this first one up here, is it probably easier to just do polynomial?
Yes.
Yes. Let's practice it using product rule. Anyway, the rest of these we're gonna have to use it anyways. Okay. So up here, let's try and do it. Let's see how good you guys are. Let's go straight to it.
But Mr. Wood, that word let's say, for example, x of x, is that like gx? I think it's gx.
Well, if this gives you a hard time, the notation, you can always change this to h of x, and then make this f of x and this g of
But
x.
that will give you that, it doesn't matter.
Because if you watch, what I'm going to do here is I'm actually not even going to bother writing it out like we did. Because I think you guys can handle it. So remember, the first part was f prime. So the derivative of that first bracket is what? Plus 3. Then we multiply it by the second one. We don't change the second one. Right? Then we add the first one, which is 2x squared plus 3x, multiplied by the derivative of the second. What's the derivative of the gx there?
4x plus 3x.
Just 2x, right? The 4x plus 2 was the first one. Now we're doing the second one. Okay? So the derivative of this one's just 2x. What? Why are you mad? What? Because it was originally f prime. Sorry, with our new notation, this would be h. I apologize. Will you forgive me? Excellent. Now, you don't always have to do it, but it's good practice for us anyway, so let's collect all the like terms and kind of, put it into a single polynomial. So this one's going to be 4x cubed minus 12x plus 3x squared minus 9. And over here, when we multiply the 2x in, we're going to get 4x cubed plus 6x squared. And then our last step is let's put all that stuff together. Now, you're not always going to have to do this, guys, but if it's a multiple choice or something, you might need to simplify it, or I might ask you to write it as a simplified polynomial, etc. So it's good practice. All right, so I put all my x cubes together. I'm going to get 8x cubed. Then I've got 3 and 6x squared, so that's plus 9x squared. Looks like I just have 12x and minus 9. And so that would be my final answer. Any questions, or does that one make sense? Come here. Does it make sense? Emma, when did you change your name?
What?
When did you change your name? I asked Camille. It's all good.
So when you do the method, you don't need to use the power.
I mean, technically you're still using it because we used it when we took the derivative of these two subfunctions, right?
Only in that part, like then after.
Yep. Now this one again, this is technically probably easier, right? To shove it all together. But again, let's try to practice the product rule. So let's see if we can do it this time. You know what? I think we're gonna have to write this out first. Let's write a little side thing here. So if I have the square root of x squared, or sorry, the square root of x, then that means that y prime would need to be 1 over 2 square root x. We've done that quite a few times before, right? This is x to the 1/2. The 1/2 comes in front. Then I subtract 1. 1/2 minus 1 is negative 1/2. So this is one that, honestly, you guys are going to memorize this because you do it so much. Okay, trust me. All right, so that's what that should be. So the derivative of that is 1 over 2 square root x times the original second function, so x squared minus 3x plus 2, plus the original first function times the derivative of the second. You guys can probably give me that one. Maho, what's the derivative of this set bracket here? Yeah? Minus 3. Thank God for Camila. All right. Now, this is an example where, like, I don't know that you would really need to simplify this one. The one simplification you probably would see is this written as a single fraction and maybe simplify the exponents, but it's not really the end of the world. It's okay if you leave it like that if you're not specifically told to make it simpler. Or it's a multiple choice.
How do you multiply 1/2 square root x times x squared?
All right, so if we put these together then, right? X squared over root x. What is that? X squared over x to the 1/2. You subtract them. What would you get? Okay, let's write it out separately. X squared over 2 root x minus 3x over 2 root x plus 2 over 2 root x. And then over here, we're going to multiply them. So this is a half. What's 1/2 plus 1? So we got x to the 3/2, and then minus 3 root x. All right, you can simplify all those ones in the middle there, or those first ones. This one?
Yeah.
3x over 2 root x, yeah. Okay. Why am I putting them all under over 2 root x? Because it's easier to simplify them that way. And if they have a common denominator, it doesn't matter if we write it as one denominator or 3 separate ones. Okay, what's this one? 2x over x to the 1/2. In other words, 2 minus 0.5. 3/2. So this is going to be x to the 3/2 over 2 minus, what's 1 over x to the 1/2? Like x to the 1 over x to the 1/2. Subtract them. What's 1 minus a half? 1/2. So we're going to get 3, might as well write it as a square root. So 3 square root x over 2. In this one, just the 2's cancel. So let's maybe write it as like x to the negative 1/2 or 1 over root x. I don't care which way you do it. Plus 2x to the 3/2 minus 3 root x. Now, you can combine a couple of like terms. They're a little annoying because there's fractions, but you can do it. Right? So here we got x to the 3/2 twice. So this would be like 4/5 over 2. You guys see how I'm getting that? If I have 2 wholes and a half, that's 2.5, right? 2.5 is the same as writing 5/2. I like fractions. You're going to learn to like fractions. What? I mean, I basically don't let you use a calculator. I do. I'm just kidding. You will use it. And then that one's going to be by itself. So plus x to the negative 1/2. And we're done. I think that's a simplified version. I don't think I can combine anything else. No. All right. Now we can move. Oh, sorry. I can't help it if I'm fast. All right. Next 4. We'd have to use product rule, right? Because we got a bunch of like trig in here and stuff. Oops. All right. So this one, again, we're going to do it without writing it all out. I think you guys have got the idea. So derivative of the first times the second plus the first times the derivative of the second, right? What's the derivative of the x cubed? 3x squared times the original, so sine x, plus x cubed, the original of the first, times the derivative of the second, which is cosine x. You're done. Easy, right? All right, let's try the next one. H prime of x. That's it. That's all you can do. Can't simplify anything. All right. Over here, the derivative of the first thing there, 3x plus 2. Just 3, so it's 3 cos x. Plus 3x plus 2. What's the derivative of cos? All right, here's what you're going to do. Look, watch. I don't want you to write minus sign because somebody's going to think it's minus sign. You're going to move the negative out front. You don't have to, but trust me, you'll make less mistakes. Okay? So instead of writing like negative like this, right, someone's going to mess that up and think it means minus. And so I like to move that negative to the front. Okay? Move it to the front of the term. If you don't do it, it's not wrong. It's just that you're more likely to make mistakes. Years of teaching this have taught me that more students make mistakes when they leave the negative in the middle or the end. And guess what? you're done. There's nothing else you can do. All right, next one. G theta. Does it matter that I switched theta for x? No, I solve it the exact same way. So, what is the derivative of 3 theta or 3x? Just 3. Now I have a product rule because I've got theta times sine theta. So now I got to do a product rule. What's the derivative of theta? 1 times sine theta. So do I need to write the 1? Is it wrong if I do? No. So if you want to write it, I don't like writing it. Okay. Plus theta. And what's the derivative of sine? And we're done. Like, there's nothing else I can do to simplify that, right? Unless I had a theta, I can't do anything. Why am I what?
That's the end of side. Instead of multiplying.
Because they're two separate things, guys. Look, this is 3 theta, which is just 3.
Yeah.
This, look at this. This is theta sine theta. The derivative of that is this. Whereas the derivative of the 3 theta is just 3. There's no product rule necessary for the first part, right? Because it's just 3x or 3 theta. Does that make sense? Yes? No? No? So what about if I had something like this, guys? If I had like 3x plus 4x squared, what would I do? I would take the derivative of this separately and then the derivative of this and add them together, right? Isn't that what I did up here? I took the derivative of 3 theta, which is 3. Then I took the derivative of theta sine theta, which is a product rule, and I added them together. Plus sine theta plus theta plus theta. For the second part, only for this part. This is the product rule. This part here is a product rule. That first part is just a power rule, right? It's just 3x or 3 theta. All right. Last one over here. What is the derivative of sine? Cosine times cosine? Cosine squared x, exactly. All right, then I'm going to add to this. Sine times the derivative of cosine is negative sine. Right, so you'd get like sine times negative sine, which is just negative sine squared. So again, move the negative to the front for your sake, you'll make less mistakes. Okay, if you leave the negative at the back, you're just more likely to accidentally write minus sine. And that's not it. Any questions?
If I move it up front, how will it look like?
Like this. Because the original way of doing it would have been this. Cos squared x plus sine x times negative sine x. I don't know about you, but this is a lot easier to look at and understand than this. So that's why I move it to the front and I square the signs, right? You don't have to, but it's a more efficient way to write it for sure. All right. Let's find the equation of the line to the graph of g of t when g of t equals t squared cos t. And we're going to do it when time is pi over 6. All right. So if I need the equation of the line, that means I need pot and sod, right? So let's find my pot first. Well, that's just pi over 6. And then I need to find g of pi over 6. G of pi over 6 is going to be pi over 6 squared cosine of pi over 6. What's pi over 6 squared? Yeah, pi squared over 36. What's cosine of pi over 6? Use the unit circle. Good. Root 3 over 2. And then I can combine those, and I'm going to get kind of an ugly number. Root 3 pi squared over 72. It's ugly, but it's just a number. Right? It's just an ugly number. Don't judge it for being ugly. And you don't judge me for it. Oh, man. All right. So then I need the SOT, right? In order to find my SOT, that means that I need to go ahead and figure out the derivative of that thing first. So that means I need g prime of t. Well, what's the derivative of t squared? 2t times the original second function, so cos t, plus t squared times the derivative. All right, so is t squared negative sine t. So remember, I'm going to move that negative to the front because I think we make less mistakes. So let's put it up there. All right, there we go. Now I need to find g prime. You know what? We're going to actually do this. Hang on, I'm going to move that. It's going to be ugly as sin. So let's put it up here. G prime of pi over 6. Are you ready for the ugly number? All right. 2 times pi over 6 times the cosine of pi over 6, which we already said was root 3 over 2. Pi over 6 squared, we already figured out that. That's pi squared over 36. Sine of pi over 6 we haven't done. What was that one?
That's
1/2. Can I combine a bunch of this to make it simpler? I mean, I can at least combine the fractions, right? So this 2 cancels with that 2, and I'm going to get root 3 pi over 6 minus pi squared over 72. That's my SOT. Or I guess we could put it together. You want me to put it together?
No.
Ouch. I'm going to put it together. So, or we could change this one to be over 72, which means we need to multiply it by 12. So we'd get 12 root 3 pi minus pi squared all over 72. All right. Are you ready for the ugliest line you've ever seen in your life? Daniela, are you ready? All right, perfect. So here we go. Ready? Here's our ugly line. Y minus y1, which is root 3 pi squared over 72, equals the slope, which is ugly as hell, 12 root 3 pi minus pi squared over 72, bracket, x minus our x coordinate pi over 6. Ugly? Ugly. Does it matter? Nope. Doesn't matter whatsoever that it's ugly.
How did you go from the square root 3x all the way to the other number?
Which one?
From the 3 square root 3 pi over 6 minus pi squared.
Oh, to this?
Yes.
So what do I need to multiply this by to get a common denominator? Yeah. So I just multiplied this one by, like I just went 12 over 12. Right? 12 times 6 is 72 to get that common denominator, and then the top just became 12 root 3 pi. All right. Guys, if you didn't like that ugly number, what could you do?
What?
What could you do if you don't like the ugly number?
Nothing.
You could just like turn it into a decimal.
Oh no, let's try it like that.
I like ugly numbers in the sense that you should get used to ugly numbers because real life is messy and uses ugly numbers. Okay? Real life is very rarely, you're going to be like, oh, the number's 3. Like, no, it's not. Okay? Real life answers are ugly.
Could you use this math in real life? Like everyday usage?
This one here?
Yes.
Let's say that equation represented, I don't know, the cooling of a fluid in an engine, or the temperature of the fluid in an engine after t seconds. And then you could figure out how fast it's increasing or decreasing, which would tell you how to basically manufacture the car to make sure that it does it faster or slower, how big your radiator needs to be.
I think I will
Have I lost
do
you?
that in my
You
life.
have to use trigonometry for that.
I mean, it depends. Basically, you need to use trigonometry every time you have something that's periodic. So, for instance, like let's say instead you wanted to figure out the height of the tides, right? That's periodic, so you would have to use a cosine function to do it, or sine to model it, and then you would modify that equation, which I'm aware you guys don't know how to do very well from pre-calc, but you would set up that equation, and if you found the derivative, you'd be able to tell me how fast the level of water is changing at any particular time of day, because it doesn't change the same all the time. I mean, you guys asked how to apply it, man. Don't ask the questions you don't want to know the answers to. No, but guys, the truth is, for derivatives, there's a lot of application. Camila, what is the derivative, like, what does it represent?
The derivative is the slope of the
And what does the slope of the tangent line mean, though? Like, what is the derivative or the slope of the tangent line?
The steepness.
The steepness. So, like, it's the rate of change. So, think about your life. You have rate of changes all the time. You drive, that's a rate of change, right? You get older, that's a rate of change. How much something costs? Rate of change. So, you deal with rates of change all the time in your life. So, derivatives are super helpful. Okay, because it's all they do is they find derivative, or they find the rates of
They
change.
use that in business.
Yeah.
pero-
Yep. All right. Good talk. Let's move on to some graphs.
pero en business.
All right, so P of x is equal to f of x times g of x. And we know that Rx is equal to x squared times gx. We're going to use these graphs to figure them out. All right. So if I take a look at this first one, I know that g prime of -4 is 2. Probably means it's going to be hard to find. And they want me to find p prime of -4. So let's start by finding p prime of x, because I can't figure out p prime of a value until I know what p prime of x is. Right? I got to find that first.
And how do we know what the prime is?
Well, we know that's what we're gonna figure out. P is up top. F of x times g of x. So we're basically just gonna write the definition for now. Right? It would be f prime of x, g of x, plus f of x, g prime of x. Then we're gonna use our graphs to try and figure out what these are at -4. Now, if you need to, you can go ahead and write f prime -4, g -4, etc. I don't think you need to. I think you're smarter than that. So, f prime of -4. So we're going to go to the graph of f. Oh no, it's a graph of f. That means the derivative is what? The slope of this graph, right? So let's hope that we can find it. We go to 1, 2, 3. Here's -4. It's on this part of the line. What's the slope of that line? -1. So the derivative of like f of prime of -4 is -1. Why? Because the slope is -1. Okay? What is g of -4? Go over here, we look over here, g 1, 2, 3, 4. Up here, it hits the graph right there, which is at 6. F of -4 happens to be exactly the same as the slope. It is -1. That's a fluke. Don't expect that to always be the case. Okay? And g prime of -4, if we go over here, that's a curve. We can't tell. There's no way to know. So that's why they gave it to us. They said, hey, by the way, this one's 2. Okay? So we know it's 2. Then we just put all that together. -6 minus 2 means that it is -8. So p prime of -4 is just -8. Okay? The derivative of what? Hang on. The derivative of f of x, what I did is I went over here, I found that, oh, it's on this part of like a line, and I know that the derivative is the slope of the tangent line, or the slope, so I just found the slope of that line. Guys, you're going to be asked to do that a lot. It's pretty common that they'll give you like a line, because then you can find the slope, and they'll see if you know what that is. That's how you get it. Product rule? What do you mean is what?
Is what we did?
Yeah, it's what we're doing right now. It's like f prime g plus f g prime. Or u prime v plus u v prime. It's written up there on the big 3. If you see the poster up there, big 3. Big 3. There it is. All right. Before we move on to the next one, let's write the tangent line here. That means I need a pot. My pot is -4. And that means I need to find p of -4, which means I need to find f of -4 times g of -4, right? Well, we found the two values. We didn't put them together. So f of -4 was -1. G of -4 was 6. And I'm just getting these from the previous one because we already did it. Which means here that my pot's going to be -4, -6. Are you all with me on how I got that?
Yes.
Okay. Then I can find my SOT, which we just did. We literally just did. What was it?
-6.
Good. So then we write out the equation. Y plus 6 equals -8. X plus 4. Yeah, the pot's a coordinate. You're welcome. That makes sense to everybody? We feel good? You feel great? Okay, well, I tried. Shall we do the next one?
If you want.
I do. but don't call me miss. Miss? All right. R prime of negative 2 equals 20. What is the value of G prime of negative 2? All right, so first of all, what we need to do is, we're probably going to need to start the same kind of way. R of x is equal to, now this one's different, remember, up here, it's x squared gx. So in order to take the derivative of that, it would be 2x gx plus, product rule, x squared times g prime. Are we all in agreement that that would be the derivative of x squared gx? Right, because we got to do product rule. And we're all feeling like we're strong on product rule now? Hopefully. Miguel, you feeling good about product rule? Excellent.
That is nx over h
Say it again?
nx to the power of n minus 1.
We're going to get there. Yeah, we're going to do, yeah, exactly. It's like x to the power of 2 becomes 2x to the 1. Yeah, exactly. Yeah, that's the power rule. Okay, so now let's plug it in. We need to find it at negative 2. So r of negative, or r prime, I should say, of negative 2. I forgot that that was prime, my bad. Equals 2 times negative 2 times g of negative 2. What's g of negative 2 if we look up there? G negative 2 goes down here. It looks like it's negative 3. Plus negative 2 squared. G prime of negative 2. Uh-oh. I can't find that. I can't find it, right? Because it's a curve. But they gave me this one. They didn't give me G prime of negative 2. They gave me R prime of negative 2. So this is 20. So 20 equals, let's see, negative 4 to 12. Plus 4G prime of negative 2. Could I now solve for G prime of negative 2?
Yes.
Absolutely. So that's what I'm going to do. Move the 12 over. I'm going to get 8 equals 4G prime of negative 2. Then I'm going to divide both sides. And so 2 is equal to G prime of negative 2.
Okay. And that's it.
That's it. Make sense? So we just gave us a different starting parameter so we can find a different part of the equation. And then I can use that, some of this information, to find the line of the tangent line. So, careful here, but let's start with the pot. First of all, it's negative 2, and then we need to find r of negative 2, which is negative 2 squared g of negative 2, which is 4 times, what's g negative 2? I forget. Negative 3, perfect. Which means it's negative 12. So my pot is negative 2, negative 12. My SOT they gave to us, I didn't even have to find it. This is the one that was just 20, right?
It's just 20.
Yeah, they gave it to us, remember? R prime of negative 2, they gave it. So then it's r plus 12 equals the slope times x minus the x coordinate, so x plus 12. Or x plus 2, sorry. Amazing, yeah? Guys, we're going to do it. We're going to do it. We got 1 page left. We can do it.
In 5 minutes.
What do you mean 5 minutes? 15. We got time. We got time we haven't even thought of yet. I think I'm losing the twins, though.
Me too.
You're losing the twins? Dude, you lost the twins a long time ago. They're already taken.
Who?
The twins.
I'm also already a little bit taken. He's taking out. I don't want to learn.
Does your girlfriend know you're only a little bit taken?
Take?
Never mind. I'm just saying, I think your girlfriend might be mad at you if you told her that you were only a little bit taken.
Ah. Naked?
Taken. I don't think you're getting me, man. I think B needs to sleep more. He's not following.
I studied, yes, no.
Kind of. They're a little different. The derivative is the actual derivative. It is the rate of change. Differentiable means you could take the derivative. It's different. All right. So now what we're going to do is we're going to look at this. Remember I said we love chart questions? Here's a chart question. All right. Here's our chart. We got f, g, f prime, and g prime. I love it. All right. So estimate the value of f prime of 3.5. So remember when it says estimate, what did that mean previously? What kind of line did we use?
Best fit.
Kind of. We call it as a secant line using the two closest points. So 3.5 would be between these two, right? So I'm going to use f of 4, that's y2, minus f of 3, that's y1, over x2 minus x1. Does that make sense to everybody? Going back to like pre-calc? Yeah, give me that. Because it wants us to estimate it between 3 and 4 for like the derivative. If you did f prime, you'd be finding the second derivative, which we're not there yet. Okay. All right. What is f of 4? 1 minus f of 3, negative 2, so minus negative 2, all over 1. 4 minus 3 is 1, which is 1 plus 2, so it's just 3. So this means that f prime of 3.5 is approximately 3. What's up? For what? Oh, right. I just looked at the chart to get the y values for 4 and 3. Do you have an actual question or just a bunch of whats? A bunch of whats? I can't help a bunch of whats. Which numbers? Where did I get 4 and 3? Because what are the closest numbers? What are the closest numbers to 3.5? 4 and 3. Remember secant line? We use the two closest ones. All right, let's try this next one. Q of x is this weird function. What is the value of q prime of 4? Well, q prime of x is going to be 2f prime of x minus 4 g prime of x, right? There's no product rule, right? Because if it's just a coefficient, I don't need to do a product rule. I can, it won't help me. Okay, so all I need to do is take the derivative of these two things. Once I've done that, I can start to fill in what I know. So g prime of 4. What is f prime of 4? If you look in the chart. Good. All right, it's 2 right here. Minus 4 times what's g prime of 4? Same thing in the chart. There we go. Then we're just going to put all that together.
It's supposed to be a Q for the first.
What's that?
In the second part, it's a Q, the G. The G.
Oh, that's a Q. Thanks. Yeah, you're right. I wrote it as G. It should be Q. Thank you. 2 times 2? I'm just not done yet. Plus 12. So it's 16. So Q prime of 4. I just wasn't done yet because they asked me a question. Sorry. Does that make sense?
Yes.
Camilo, what's up?
That's Q prime, what you wrote, right?
Yep, Q prime of 4. Daniela, did we break you?
Yes.
My Q looks like a 2. How does this and this look the same? What? What kind of ugly 5s are you drawing? I think the problem is you, dude. I'll take a little bit of responsibility because I know I'm messy. All right. Should we keep going? I'm so happy that whoever you're talking about is super cute, but can we do the next question? Emma. Maho. Stop wasting everyone's time. All right. Well, if you're all talking, that must mean you guys know how to do it. So go ahead. Let's do it. I'll walk you through it without talking. Really? Emma, you're behind, girl. Okay. Guys, what I want you to notice about this one is that the p prime of x, that negative 2 is going to go into everything. So the easiest way to handle it is to pull it out front with a big set of brackets or parentheses, okay? Then we're just writing the product rule because f of x times g of x is just a product rule. And so then we can go ahead and start working these all out based on the fact that we're plugging in 3. So if you look up top for me, because I can't see it, What is f prime of 3 from the chart? Negative what? Okay, and what is g prime, or not g prime, g of 3? Okay. And then I need f of 3 and g prime of negative 3. Or g prime of 3, sorry. All right. And then we just need to start putting that all together, right? So negative 4 times negative 3 is 12. Negative 2 times 2 is negative 4. So it's going to be negative 2 times 8, or just negative 16. So p prime of 3 is going to be negative 16. Easy enough? Not too bad? All right, next one's a little bit trickier. We got to find the equation of the tangent line. What do you mean we're done? You're done? You're turned off your brain? I'm sorry.
Yeah. Let's leave it.
No, come on. There's only 2 questions, guys.
Where the section advances the most?
Usually you guys, but not always.
Today, yes.
Today, yes. The other class didn't finish. They have the whole back page. Bean. Cállate.
Cállate.
All right. Now let's do it. Let's do it. Let's do it. You guys, you can do it. Stop complaining.
I have a question.
Okay, that's fine.
Why is like one parenthesis and one bracket? Or is that doesn't matter?
Because I made a mistake. It should be the same. Yeah, they should be the same.
Paying attention.
Look at you go, Maho. All right. So x cubed becomes 3x squared times the original f of x plus x cubed times f prime of x. We all in agreement so far?
Yes.
Right? Just a simple product rule. Good. Now we're going to find it at negative 1. 3 times... What do you mean, what am I doing?
No, you.
Oh, well, he's weird. All right, so I'm going to plug in negative 1 squared, which is 1. What's 3 times 1? 3. Let's just do 3. Let's not write the other stuff. All right, what is f of negative 1 if you look up top? What? 2? Perfect. Then I'm going to get negative 1 cubed. What's that?
Negative 1.
Good, so we're going to go negative 1. What's f prime of negative 1? So it's just going to be minus 1. All right, so we got 6 minus 1, which is just 5. But I need the equation of the line tangent to the graph. So that means I also need to go find my pot real quick, which luckily I can just look up there. So if x is negative 1, what is f of x? Oh, no, I can't do that. Never mind. I got to plug it into here. I'm crazy. I need v of negative 1, which will be negative 1 cubed is negative 1 times... What was f of negative 1? We already did it, right? 2? Wasn't f of 1 2? F of negative 1 is 2?
F of negative 1 is 2.
Yeah, 2. That's what I thought. So it should be negative 2. So my pot...
No, wait.
Okay. So I go up here and I look. F, when x is negative 1, f is 2. Okay? And so the v of negative 1 is negative 1 cubed, which is negative. And then f of negative 1 is 2. So it's just minus 2. Okay? Then I can write my equation. Y plus 2 equals the slope of 5 times x plus 1. Right? Because I got to split the signs of those negative 1, negative 2. Last one. We can do it. We can do it.
Yeah, we don't have time.
Maho, you have time.
I mean,
Maho, you got nothing but time. Besides, your next class tomorrow is a flex block. So if we get it done, tomorrow you can just work. Or do... All right.
is there what is the case?
Oh, I don't know. Not for a long time. We just started the unit, man.
But like, the last year.
No, you don't have to do a test because it's the same stuff. It's just more of derivatives. So I don't do an exam after. I do it at
So
the
you're
beginning.
doing a test for 2 units.
I mean, technically.
But it's going to be longer.
No.
Yeah.
Don't panic, guys.
So let's do another precalculus review as a test summary.
All right, let's go through this. So I need to take the derivative of this first part. What's the derivative of 2fx plus 3? Yeah, 2f prime x. Good. Multiplied by the second one, which is 3 minus gx, plus the first one, 2f of x plus 3, times the derivative of the second. What's the derivative of that second bracket? Close? Negative g prime x. There you go. Good. All right, now I need to figure it out when it's 3, right? So this is going to be 2 times f prime of 3. What's f prime of 3 if you look up top again? Negative 4. Okay, then we're going to multiply that one by 3 minus g of 3. What's g of 3? Isn't it negative 3?
Yes.
Yeah, okay. So 3 plus 3 it becomes. All right, 2 times f of 3? Negative 2, okay. Plus 3. And then negative g prime of 3. What's g prime of 3? 2? So it's minus 2 then, right? Because it's negative g prime of 3. Then we just start putting all this together, guys. So this part here is going to be, what, negative 8 times 6? And then over here, this is going to be negative 4 plus 1 is negative 1 times negative 2 is plus 2. What's negative 8 times 6? Negative 48 plus 2, so we get negative 46. So k prime of 3 is equal to negative 46. Easy enough, right? We're done.
No.
With 2 minutes to spare, Maho.
Mr. Motherfucker.